Students of economics, welcome back to yet another teaching module. This is teacher Shirley and today's topic is arithmetic line graphs, which comes under the topic of presentation of data. We have already covered so far histograms, frequency polygons, frequency curves and ogives. Now we're moving on to the next and last part of the topic presentation of data. Stay with me. Alright then, let's begin. What is an arithmetic line graph? An arithmetic line graph is also called a time series graph. And in this graph, time could be hours, days, weeks, months or years is plotted along the x-axis. And the corresponding values of the variable is plotted along the y-axis. Arithmetic line graphs or time series graphs can be mainly of two types. They can be one variable graphs or two or more than two variable graphs. Now you can see here in the illustration, you can plot so many variables. Like for example in the stock exchange market, you have the Sensex, the indices or index numbers of the share prices of 50 stocks that are there registered with the Bombay Stock Exchange. And you can see this is done with respect to time and the data is plotted. So what is the Sensex index numbers on various dates in April up till the date 22nd of April. And so you can study the variations that happen in the stock exchange indices or index numbers. So here also intraday. So this is intraday means you can classify data on the basis of time, right? So from 9 o'clock in the morning till 4 when the market closes. So you can see the changes in the index number that is happening. That means it gives us an inkling of how the stock prices are changing, rising or falling during the entire day. So that means we can use time series graphs even to help us to study data with respect to hours or time. And normally a time series graph is done with respect to hours, days, weeks, months, years, and so on. The line graphs have various applications. The line graph is a powerful visual tool for marketing, finance, and other areas in business. It is also a useful tool in laboratory research, weather monitoring, and any other function involving a correlation between two numerical values. For example, you can correlate time with so many other variables. You can study expenditure, profit, income of a firm for a week, for a month, and so on. So if two or more lines are there on the chart, it can be used for comparisons to compare different variables. So it becomes a very useful tool in economics and business and other areas as well. Arithmetic line graphs, as I told you earlier, or time series graphs as they are called, can be one variable or can involve two or even more variables. Now what are one variable graphs? They are those graphs in which values of only one variable are shown with respect to the same time period. So for example, if you're using years, so in different years the profit is different, right? So we can measure profit or state the profit of a firm, for example, for different years and plot this with the help of a graph. The same table that you saw earlier is now plotted with a time series graph. So here you have the profit in thousands is 50 here. So on the y-axis you take the dependent variable and on the x-axis we plot the independent variable. Why? Because the variable that is on the x-axis does not change, does not depend on profit. However, profit can be expressed for different time periods. So here profit is the dependent variable and so we plot it on the y-axis. Now here we only use one variable, and what is that variable? In this case it is just profit of a firm in thousands. So for the year 2015 we plot the point 50 for the year 2016, 62 is plotted. You could even highlight this area with a dot. So time series graphs are often expressed as dot to dot lines. The profit in 2017 is 65,000. The profit in 2018 fell down to 55, and so that is plotted against the number 55, which is seen on the y-axis. And again in 2018 the profit rose to 70,000. So see, it is so easy to visually explain and even express what you would like to show. So this is a very useful tool because visually at one glance we can understand how the profit has changed over the years. Now moving on to the two variable time series. So we can draw a time series graph for this data. Well, in this case you have the output or production or yield of wheat in 1000 kgs and rice in 1000 kgs. So here you have two variables. Which are they? Wheat and rice. So the quantity of wheat and the quantity of rice is expressed for various years starting from 2015 to 2020. This can be expressed with the graph that you're going to see now. Here you can see the yield or the output or the production is plotted along the y-axis and the various years are plotted along the x-axis. So in one case there's a legend here. You need to say which color code you are using to express which variable. So in this case the darker shade of brown shows the output of wheat and the lighter shade of brown shows the output of rice in 1000 kgs. So this curve here is expressing the yield or output of rice. So you can see that the output of wheat is also shown on the same graph or plotted along the same graph. So what do you have to do? You have to look at the first and the second column to plot the output of wheat, and then look at the first and the last column and plot the output of rice. Together they are shown on the same graph. So that makes it so easy to compare the data, right? So you can see that in the year 2017, the output or the yield of rice rose steadily from 50 to 100 to 150, whereas the output of wheat rose initially from one year to the next, and then there was a drop. So when you have a fall like this, it gives an indication to the researcher or policy makers to try to understand and investigate why this could have happened and how this can be resolved. So you can draw conclusions out of interpreting and understanding your data. And we have another table or tabular representation of data which we need to translate or convert to a graphical representation or graphical form. So we're going to construct a time series graph to present the following data. And this data relates to expenditure and income of residents in a town from the year 2015 to 2020. As you can see, there are two variables. One is expenditure in lakhs and one is income in lakhs. Let's plot all these data onto a graph. So here we have represented expenditure and income. In the legend we show the color coding, and so initially we plot first for expenditure and then we plot the points for income. Here again income and expenditure in rupees, a lakh rupees is plotted along the y-axis and the year is shown on the x-axis, and it is so clear to see that the expenditure in 2017, for example, there is a peak here, and as well as there is an increase in income, and then there is a sharp drop right down to 10 for expenditure in lakhs and 12 for income in lakhs, and then in 2020 there has been a slight rise. Here again we're going to present this information with the help of an arithmetic line graph. Again, this is a two variable line graph or time series graph. And here you see we are showing cost and profit. So you can see how we are using line graphs in economics, in finance, in business to express various variables and data. So we're going to plot all this data again with the help of an arithmetic line graph. So here we have the table that has been represented in the form of a graph or diagram. That means we have converted tabular representation of data to a diagrammatic representation of data. Here we have the two variables, cost and profit, that we saw in the table has been plotted along the y-axis along with the numerical values here, and you have the years plotted along the x-axis. Once you draw your x and y-axis, the first thing you need to do is label your diagram. The legend need not be shown below the x-axis. It can be shown in the top right hand corner of the diagram. So we see the darker brown we have shown cost and the lighter color we have shown as profit. We can analyze and interpret this diagram and see that profit has increased gradually from the years 2015 to 2017. There has been a slight fall in the profit from 90 to 70 lakh rupees in the year 2019, as well as the costs have risen by this extent. So you can analyze, interpret, and a firm can work out how they can solve and resolve issues just by observing and studying the tabular or diagrammatic representation of data that they have collected. At this point, you might have realized that we are not only just learning to draw the arithmetic line graphs, which is rather simple actually, but here we want to stress on the importance of being able to interpret diagrams, to understand, to analyze, and to explain them. When you go to the 12th standard or even further on when you study, you will be studying economics and you will be studying micro and macroeconomics, where you have a host of diagrams and you need to explain those diagrams from the examination point of view, and you have to develop that skill and ability right now itself. So what I want you to do further on now with the diagrams that I've shown in the video, I want you to be able to interpret the diagram or at least explain the diagram. So the graph reflects changes in growth rates of the primary, secondary and tertiary sectors of the Indian economy from the years 1994-95 until 1999-2000. So you can see we have the agriculture and allied services, we have industry and services. You see that industrial growth rate fell initially and then it picks up in 1998-99 and goes upward. There's an upward trend. Services, on the other hand, has been quite stable from the year 1997-98 up till 1999-2000. However, there has been a peak in the growth rate of services in the year 1995-96. Whereas we can see that there has been a drop in the growth rates, even negative growth rates of agriculture and allied services in 1995-96 and 1997. But there has shown a pickup in the growth rates and then a fall. So there has been an erratic behavior of growth rates of agriculture and allied services. You see so beautifully it has been shown, the scale has been shown that 1 centimeter represents 1% growth, and along the x-axis 1 centimeter represents 1 year, and the diagram has been labeled as well. So when you explain your diagram, the first thing you would do is say, explain or write down what is shown along the y and x axis, and then go on to explain the changes in the variables that we are talking about. Here we have yet another diagram that I have shown that I want you to interpret. I want you to try to interpret this time series graph. This graph shows us the import and exports pertaining to India from the years 2009 to 2014. I want you to examine, interpret and explain this graph. So as you are doing it, you can pause the video, look at it, view it, and try to explain in your own words how you would interpret or explain or understand this diagram. Here we have a quote by Daniel H. Wilson. I chose it because it speaks about graphs somehow, and I found it really interesting. I thought I'd share it with you. He says, quote unquote, "You can graph human evolution, which is mostly a straight line. But we do get better and change over time. And you can graph technological evolution, which is a straight line that's going straight up. They're going to intersect each other at some point, and that's happening now. I'll leave you with that thought. Thank you so much for giving me a listening ear. Please complete all the work that's been allotted in this video as well as the homework that is given to you. Thank you.